Hello students, welcome to SGT Classes, and in this video we are going to discuss about quantifiers, quantified statements, then negation of compound statement, duals, then converse, inverse and contrapositive of implication. Okay, all these things we are going to learn in this video, but before starting video I am going to explain very short. Please try to understand. Let's start. Okay, now see that there are two quantifiers there exist, and for all. Okay, for all implies there should be all factors present in the given statement. Okay, and there exist implies that there at least one factor should be present in the given statement, then that statement is true. And for all factors should be present in that statement is true. So let's start from one of the example. A is the set of 1 to 7 numbers. Determine the truth values of following. Okay, so first I have this quantifier there exists. Okay, x is a set of a such that x minus 4 is equal to 7. Therefore I will solve this. X minus 4 is equal to 3, therefore x is equal to 7. So 7 is present in the given set, therefore this is a truth statement. This is a true statement. Okay, there exists means at least one factor should be present, therefore truth value is t. Okay, therefore truth value is t. Okay, in this way you have to solve this. For all x is a set of a such that x plus 1 is greater than or equal to 3. Okay, therefore I will try to solve this. If I take 1a, I will get 2. Okay, therefore x plus 1 is equal to 3. Okay, therefore x is equal to 3 minus 1 is equal to 2. Therefore 2 is there, and this 2 means x. This 2 means x. Okay, what is the given statement? This number should be greater than or equal to 3, but 2 is not greater than or equal to 3. Therefore this is a false statement. This is a false statement. Okay, false statement. Okay, therefore this is a false statement. You have to write in short truth value. Therefore truth value is f. Okay, I'm just going to explain in very short. Okay, and therefore for all x is a set of a such that 8 minus x is equal to 7 or less than 7. Therefore 8 minus x is equal to 7. Therefore x is equal to 7. Okay, minus 8. Therefore x is equal to, okay, this 7 minus x. Okay, 7 minus x. So minus x is equal to minus 1. Okay, therefore x is equal to 1. Okay, now see that this is 1 when I do this. Okay, so x is equal to 1, I will get 7. Okay, then I will get 2, 3, 4, 5, 7, but not more than 7. So this is a true statement. Therefore this is true statement. Therefore this is a true statement. Okay, therefore truth value. Okay, truth value is t. Okay, like this. You can write in deep also for more explanation if you want. You take the x is equal to this now 1. Okay, then 2 you'll get 6, then 3 you'll get like this 5. Okay, 3, 4, 5 like this. Okay, so this is true statement. Now there exists x is a set of a such that x plus 8 is equal to 16. Therefore, okay, x plus 8 is equal to 16. Therefore x is equal to 16 minus 8 is equal to 8. Therefore this is not true statement because 8 is not present in the given statement. Okay, a given condition. Okay, therefore this is a false statement. Therefore truth value is f. Okay, truth value is f. One thing remember that there should be one component present in the given statement, and for all there should be all components present in the given statement, then only that statements are true. Okay, otherwise not. Okay, so if not true statement, then that is a false statement. So this is one of the example by which we have just learn about the quantifiers. Now we'll go toward the next point, that is the duals, and then negation of compound statement, converse, inverse and contrapositive of implication. Okay, we'll learn about duals. In the duals you have to just alter the symbols in the given statement. Okay, so or goes to change into and goes to change into or, and this means contradiction goes to change into tautology, and tautology goes to change into contradiction. Okay, you have to change these all symbols, and you have to do nothing with the negation or any other symbol. Okay, only you have to change these symbols. Okay, so see here, first example, therefore dual of, or its dual is, okay, therefore its dual is, therefore its dual is, okay, what is given? P, this is given and, so it will be R Q, and this is given or, it changed to and R. Okay, so this is the dual of the given statement. Okay, or you write triple is equal to sign, okay, this equivalent signs, and write the dual. Okay, so in this way, and this I am writing directly here. Therefore T means tautology goes to change contradiction, and this or goes to change and P, and this or goes to change into and Q. Okay, this is the dual for the given this. Okay, this one, this one. Okay, and now this. Okay, therefore this is equal to P, this is and goes to or, and then square bracket is there. So negation keep as it is, this is also goes to change into and. Okay, P, this goes to change into or, Q, this or goes to change into R, and negation of R. Okay, in this way. So this is the dual of the given statement. Okay, so you have to change these, means you have to make the changes in and or and, contrapositive, tautology, contrapositive. Okay, these changes only required in the duals, and you have to do nothing with the remaining symbols like negation, etc, etc. Okay, so this is nothing but your duals, and you have to just remember like this only. Okay, and now we are going to learn about the negation of compound statements. Okay, we'll learn about negation. There are 4 compound statement we know very well: and, or, if, then, and if and only if. Okay, so first is conjunction. Okay, so and, this is symbol of and, or, this symbol of or, disjunction. Okay, 6 is even and perfect number. Okay, this is one of the example. Let P 6 is prime. Okay, sorry, this 6 is even. Okay, it is prime. Okay, we'll take prime then. Okay, 6 is prime, it is even only. Okay, let 6 is even, I'm changing this into even. Okay, and there is even number. Okay, even. Okay, these are the examples in book only. Okay, 6 is even and perfect number. Okay, let's P6 is even, Q6 is a perfect number, symbolic form P, okay, and Q. Negation, you have to take all the form in the complete bracket, then negation of P, and this changes to or. Okay, and negation of Q. You know that negation, I am going to do negation, and negation में जाता है तो और बनता है, और negation में जाता है तो and बनता है. Okay, and goes to negation or goes to negation and. Okay, you remember these things. Okay, so in this way, so finally I'll get this is negation statement. Okay, so 6 is not even or not perfect number. Okay, this is the statement. Okay, this is the statement. Okay, final statement. Okay, now x is prime or y is even. Okay, let P is x is prime, Q is y is even, symbolic form P or Q. Then negation of this is negation of P, this or changes to and, negation of Q. Okay, you always remember. Therefore final statement, this is statement x is not prime and y is not even. Okay, you have to learn all these things are very easy and very simple. Okay, this is first and this is or, conjunction, this is symbol, disjunction. Now we are going to learn about next remaining two compound statements, implication and double implication. Okay, we'll learn about the implication, negation of implication and double implication in very short. Okay, now see one of the example. This is a if then, and symbol is one of the straight arrow towards the right hand side. Okay, if bakery is open, then I will buy a cake for you. Okay, this is the example. Let P bakery is open and Q I will buy a cake for you. Symbolic form P implication Q, and negation of this whole P implication Q. Okay, P and negation of Q. You know that the implication, in the case of implication, first is true and second is false, then only the given statement is false. Okay, you have to remind all that things very simply, you can understood. Okay, very simply. Okay, so remind that statement. Okay, P and not Q. Okay, so P does not implies Q. Okay, or P but not Q. Okay, you remember this. Okay, so P and negation of Q. Okay, bakery is open but I will not buy a cake for you. Okay, this is the statement. Okay, then final negation statement. Okay, negation of double implication, if and only if both sides the arrows are, the number is an even number if and only if it is divisible by 2. Okay, the let P, the number of number is an even number, the number is divisible by 2. Okay, Q. Okay, symbolic form P double implication Q. Negation. Okay, P but, this is actually but not Q, or Q but not P. Okay, both will get the same type of opportunities for the negation. Okay, don't forget this thing, because you know that first is true, second is false, first is false, second is true is false in the case of double implication, so remind all that things and just carry forward. Okay, negation, so both will get, first is true but second is false. Okay, second is true but first is false. Okay, so both are the negative. Okay, but this is the negation of the double implication, and it is very easily you can remind this. Okay, so don't forget this negation form of the double implication. So a number is even but not divisible by 2, or a number is divisible by 2 but not even. Okay, it is the required negative statement or negation of the double implication. Okay, so this is the negation for implication, double implication, and now we'll discuss the remaining part of this topic. Okay, we'll learn about converse, inverse and contrapositive of the implication. Okay, converse, inverse, contrapositive. Okay, converse, suppose C inverse I and contrapositive CP simply. Okay, let us consider one of the statement P implies Q, implication Q. Okay, now this is the statement I want to converse, inverse and contrapositive. I'm simply explain this topic. C, suppose the converse, then I have to just replace this Q at the place of P and P as the place of Q. Okay, so I will get the converse. Okay, let us consider this is theorem. Now this is the converse, this is a theorem, this is converse, this statement is theorem and this is converse. Okay, now inverse means I have to make this both of the statements. Okay, both of the statements negative. Okay, so negation of P and negation of Q. Okay, negation of P implies negation of Q. Okay, this is your inverse. And contrapositive, just right now consider this negation means inverse is a theorem and this is its converse. Okay, so you have to replace this negation of Q at the place of negation of P and negation of P at the place of negation of Q. Okay, this is the converse, inverse and contrapositive. And one thing is clear, that if you just apply your simple skills, knowledge or logic to understand all these things, now you can easily understand or understood all these things. Okay, so please try to learn and try to grasp the knowledge related to all these topics, so you can increase your vocabulary related to the mathematics, and you will get the good marks also, and you will get the good knowledge also. Okay, so yeah, I'm going to finish this video, and in the next video we'll discuss about exercise 1.3, then 1.4, 1.5 like this, and finally we'll complete this lesson. If you like this video, don't forget to like, share, subscribe and press the bell icon button, so you'll get the notification of upcoming videos on time. Thanks and keep watching. Have a nice time.